Vultures routinely consume meat laced with some of the most lethal pathogens on Earth, including anthrax, botulism, and rabies, fatal to almost any other vertebrate. To access the marrow inside, their jaws and digestive tracts are built for immense physical strain. They can splinter and snap thick, solid bone, processing the most unyielding parts of a skeleton as a primary food source. The Himalayan vulture operates at extreme geographies, foraging at 5,000 meters on the freezing Tibetan Plateau, where oxygen is depleted by 40%. This is a creature specialized through millions of years of evolution to thrive on lethal diseases in the death zone of the Himalayas. Yet across their range, these hardy scavengers are suddenly vanishing from the skies. Recent genomic mapping has provided a look at the rapid evolutionary adaptations that allow this species to survive where most life suffocates. At a cellular level, specific hemoglobin mutations allow their blood to bind oxygen with superior efficiency. While standard respiratory systems fail in thin air, their blood acts as a molecular magnet. This highly oxygenated blood fuels massive flight muscles for hours over rugged terrain. These genetic advantages turn them into the undisputed masters of the high-altitude skies, allowing them to survey vast territories for carrion with minimal effort. Once they locate a meal, focus shifts to their digestive tract, where the internal environment registers a gastric pH level hovering near zero. This is driven by the positive selection of the SLC26A7 gene, which evolutionary biologists have identified as the primary driver behind their extreme acid secretion. When they ingest bone fragments, this acidic environment rapidly dissolves the solid structures, turning calcium and marrow into absorbable nutrients. This same acid bath neutralizes incoming pathogens, breaking down viruses and bacteria like anthrax spores before they breach the stomach lining. These genetic adaptations make vultures nature's primary sanitation system, actively removing dangerous biological waste from the environment for all other species. Life on the Tibetan Plateau is defined by geography. The rocky, frozen, and timberless environment makes traditional burial or wood-fueled cremation nearly impossible. For centuries, the local population has relied on an ancient practice called jator, or the sky burial, as both a practical and spiritual solution. In this ritual, human remains are offered to the vultures. The process frames the birds not as scavengers, but as a sacred ecological necessity. The vulture's evolutionary biology isn't just a scientific anomaly, it is the functional cornerstone of an ancient human culture and a delicate mountain ecosystem. In the 1990s, this ancient symbiosis was suddenly interrupted by a microscopic, man-made threat. Farmers and veterinarians began using Diclofenac, a common non-steroidal anti-inflammatory drug, to treat cattle. While vultures can neutralize anthrax, they lack the specific enzymes required to process this artificial drug. The diclofenac molecules bypass their stomach defenses, enter the bloodstream, and begin crystallizing inside the kidney tissue. A single meal from a treated cow causes rapid kidney failure. For an animal that can survive the harshest peaks, this simple chemistry is a death sentence. It took millions of years for these birds to adapt to the extremes of the Himalayas, but it took less than a decade for a single human drug to bypass those defenses and decimate their populations. This map shows the distribution and conservation status of 23 vulture species. It highlights the massive collapse across Asia, where vulture populations in India plummeted by over 95%. This collapse had immediate consequences. Millions of rotting, unprocessed carcasses began to accumulate across the landscape, left to decay without the birds to sanitize them. In this ecological vacuum, populations of feral dogs and rats exploded. These facultative scavengers took over the vacant niche, but they lacked the acidic digestion required to neutralize pathogens. The result was a massive rabies epidemic. The feral dog surge is linked to an estimated 500,000 human deaths and nearly $70 billion in economic damage. The vulture's demise proves that our quality of life is tied to the specialized species that keep our environment clean. When those biological defense systems fail, the threats they once contained inevitably reach us. Learn more about the intricate biological systems that protect our world. Click the subscribe button, activate the bell, and join us for the next scientific investigation into the mechanics of our planet, only on TEMBODocs.